Problem number 11 is asking you to use the Maclaurin series or arctangent of x to find what the value of f21 of 0 is. So f21 of 0 is the 21st derivative of arctangent evaluated at 0. So there's a couple different ways you could go about this. You could try taking 21 derivatives of arctangent, but that would take a really long time. So instead what we'll do is we'll look at the Maclaurin series for arctangent of x and see if we can derive it from there. So first off, the Maclaurin series for arctangent of x is equal to, equals 0 to infinity, negative 1 to the n, x to the 2n plus 1, divided by 2n plus 1. So again, that's a memorization one, and it's a good idea to remember some of the more basic Maclaurin series like e to the x, sine, cosine, and arctangent. I think you'll find on exams that it saves you a lot of time overall. So I'm going to go ahead and I'm going to look at this Maclaurin series and see if I can derive out what f21 of 0 is. So I know that any Maclaurin series is derived from the original expression that you use for Maclaurin series. So I know that that is n equals 0 to infinity fn of 0 x to the n divided by n factorial. Now I know that using this expression, I should be able to get this Maclaurin series. So, all I need to do is I need to figure out what n value I'm looking for. So in this case, I'm looking for f of 21. So on this left-hand side, I'm going to go ahead and I'm going to plug in f of 21 into all the terms here. Now, what I need to do is I need to find an equivalent n term on the right-hand side that will allow me to cancel out my x values. I don't want my f21 of 0 to be a function of x. In fact, it can't be a function of x because it's evaluated at 0. So I need to get rid of these x terms so that way I can figure out what f21 of 0 actually is. So, what I'm going to do is I'm going to equate the powers and try to see if I can find an equivalent n value to plug in over here. So 21 is equal to 2n plus 1 if I solve for n. N is equal to 10 in this case. So that means that the 21st derivative of my Maclaurin series actually corresponds to the 10th derivative of arctangent of x. And the way this works out is, if you remember, sometimes when you're deriving out these terms, you end up with terms that are 0. That's why the 21st derivative only corresponds to the 10th term over here, because there's a bunch of terms in between that when you evaluate them, they actually come out to 0. So I'm going to go ahead and I'm going to plug in my n value correspondingly over here, and I end up getting f21 of 0, x to the 21, divided by 21 factorial. That's equal to negative 1 to the 10, that's positive 1, so we don't have to worry about that, x to the 21 divided by 21. Good. So now I can cancel out these terms, and all I'm left with is I'm left with an expression with nothing but numeric values. So to solve for f21 of 0, all I need to do is move this factorial over to the other side. So if I go ahead and do that, I end up with f21 of 0 is equal to 21 factorial divided by 21. Which, using the laws of factorials, where it says that if you have n factorial, it's equal to n times n minus 1 times n minus 2, so on and so forth, I can actually reduce this down and say that f21 of 0 is equal to 21 times 20 factorial over 21. So I can actually cancel these terms out, and I'm left with my final answer of 20 factorial, which corresponds to answer B on exam 3.
The Teaching Center, UF's Learning Resource Center.